Hello and welcome back, and that is right, today we're returning to the subject of Plex Media Server, but today a little bit of a twist. We are looking at that Jonsbo N2 and TopTon Celeron build that we featured on the channel about a month ago. During our 100k celebration we built a NAS, and during the course of that we utilised a lot of components in efforts to try to match the kind of hardware that Synology and QNAP and the other brands putting out there, but at a much lower price. And this build here is what we went for. This is the N2 build, which has got the N5105, a quad-core processor there, 2.0 gigahertz that goes up to 2.9 when needed, and on top of that, that CPU does have integrated graphics. More on that later on. And in this video, we're going to be putting Plex on this system through its paces. We've installed TrueNAS Core, and we're running Plex Media Server Beta with all of the jail there already pre-created, and the usual media we use in our other tests all inside there. Now, we're going to have to go through a whole bunch of disclaimers for this video, because although we do a lot of Plex Media Server testing, this video in particular is going to need a lot there on the front end. So if you just have come to this video just to see how well Plex Media Server and Plex Media Access on this with and without transcoding runs on this system, fast forward. There should be chapters at the bottom that allow you to just skip straight ahead to the testing. But for the rest of you, please indulge me a few minutes to go through not only the disclaimers, but some of the pros and cons of this build for Plex. So, a number of you may have noticed that we're accessing this via the web browser. Now, yep, there is down here the Windows client that we're going for, and I will show you the Windows client in a moment because it's very important. But the reason we're utilizing the web browser is that allows us to do a lot more tailored access to the multimedia that we're going to be using in today's test. Now, whether you're going to be accessing all of your media native, that is to say playing its original format, or you're going to be converting the file on the fly, known as transcoding or conversions, that is going to be very, very important to whether this build is going to be right for you. Now, why is that? Because although this system we're using here is running on a Plex pass, which means we have access to transcoding there, we can set the transcoder to make my CPU hurt down there, we can enable hardware acceleration when needed. As you can see down here where it says hardware transcoding device, we've only got auto. Now, the reason being is, even though modern releases of Plex Media Server have allowed users to be able to see and differentiate different hardware accelerated transcoders and engines for choosing between software and hardware transcoding, in the case of this particular CPU and with Intel QuickSync, we are encountering some issues that, according to a lot of the forums that we've seen already, has been pretty persistent for a long time. Now, if you want to make this particular build take advantage of hardware acceleration, you are going to need to enable some stuff in the background. There's some handy guides do exist. I'll link to these in the description and maybe make a video about them showing you how to allow Plex to access the iGPU there on that CPU. But there's a lot going on, and even a breakdown there over on Freshports to show you exactly how to do it. Now, I've not done that for this because I think it's important that we show this build in its native state, and I'll do a separate video breaking down how to utilize this because it is not for the beginners there. And I think saying that this build can do this when you have to go through an arguably complex guide to do so, I'm not sure how I feel about just rolling that in, that this system can do it. Consequently, as we go through different tests throughout the course of this Plex Media Server test for the Jonsbo and TopTon build, number one, we're going to be utilising Plex's own dashboard there, which will give us information about how Plex is running. It will also give us information when a file is playing. So, case in point, if I go ahead here in the background and play a rather low-level file there in the background, we're just going to play that one there. You'll see on the right-hand side of the screen, it will update us to tell us that we're utilising this as a mainstream, that we're running it in its original non-compressed format there, and it's running like an absolute dream. As you can see, we're accessing it, we're not utilising any kind of encoding or transcoding. Likewise on net data here, I'm just going to rewind that back there. We can see how much CPU utilization has been effective, which is very, very low down there. And finally, we're going to be looking at system temperatures. And this is really important because unlike a lot of pre-made builds where the CPU and the motherboard and the entire enclosure itself is all built by one manufacturer, in the case of the Jonsbo build, we've gone ahead and bought components from lots of places. So looking at how the system deals with temperature is going to be very, very important. And as you can see there, At peak earlier on when we were rescanning the database and the metadata, it went as high over there as you can see around 30 degrees, so nothing really to be concerned with there. But as always throughout the course of this, when conversions do happen, we will try to highlight them where possible and what's causing them. So as you can see here in the conversions tally, nothing's being converted, and that's really it. The final thing I want to highlight, as I'm sure a number of you want to point out, is why am I using the web browser predominantly? And that's true. For example, if we go in and try and play ourselves a much more aggressive file, one that the system will be forced to transcode, or we can force it to transcode ourselves. So if we go into, for example, the list database here, we list it by name, and we go for the detailed view, and we go for an incredibly easy to play 3 megabits per second bitrate, we'll get into that later on, 3 megabits per second HD file at H.264. In other words, this will play on pretty much anything. So we play that file there, but we go ahead and convert this file manually. So we want to convert this down to 480p, which is quite an aggressive change of gear there. You'll see on the right hand side we are transcoding, but it looks like that is indeed software transcoding, which is going to be a pain. Again, we will do a follow-up video showing exactly how to get the most out of this build for hardware transcoding, but as you can see there, we're having to convert that file. Now, converting a file will use a lot more system resources, I'm sure a number of you are aware, but because we're using the web browser, we have a greater degree of control over what we're doing and the playback. Whereas, if we'd gone into the native app for Windows, and this time we go into something particularly aggressive, so rather than going for that rather pedestrian 3 megabits per second H.264 file, we scale things up substantially and go for something 10 times bigger, and in HEVC, so H.265, we're able to play back that original file, as you can see there, and if we minimize that file down there, we're able to see we're still seeing a spike in utilization, but how the file is being played will differ quite substantially in terms of transcoding and when transcoding is needed. So if we try to play back the same file that we've got here or something similar in the web browser will force that transcoding through. And we need to be able to control and cater when and how transcoding happens at numerous points in this video. So it would have been very easy for us to do this on a mobile, do it on a tablet, do it using a mobile client. But we need to use the web browser so we can access all of that statistical information there in the background. As you can see, the CPU temperature has gone up because of what we were doing there. And it allows us to visualize all of this information a great deal more easily. And again, I'm well aware that we are utilizing software transcoding at points in this video, and again, that follow-up will happen. But that's enough of the old yibba yabba. Let's get straight in with the testing itself. Now, as you can see, CPU, system load, all of this is going to be relevant information, but on the left hand side of the screen we're predominantly going to be showing the playback of these files. As you can see, there's our Jonsbo build there in the middle, and on the right hand side of the screen, that's where we're going to be hopping between different kinds of playback over and over again. So for now, let's go ahead and go for an entry-level 720p file there. If we go for the movie files there, we can go into the matrix. This is a 720p file. Again, I've had to mute this because YouTube is lots of fun and games whenever we try to reuse a lot of pre-existing media, but unfortunately when it comes to 720p we kind of have to do so. So if we play back that file there, something for you to relate to, playing back absolutely fine, it's going through sweet as a nut. We're seeing this tiniest spike during the build up there of just lining up the file, but not really anything to be concerned with there. I'm just going to kill that there in the background because it was playing there while we're doing other stuff. But for now, we can skip back and forth very easily, no problems whatsoever. Running absolutely fine, like an absolute dream there. And again, although we're seeing the bandwidth spikes when it comes to the CPU utilization, we're not really seeing any concerns whatsoever. We come out of that one, and now we're going to go for a 1080p file there. So this time we're going to go into, once again, the films, where we go for Little Shop of Horrors there. Again, we can play back this file natively. We'll go for that one there. We're not going to use shuffling. There's no point. As you can see, we're playing the original quality there, 1.9 megabits per second. Call it 2 to 3. And that's 1080p, and that's an H.264 file. As you can see there, still running there. They're on the right-hand side of the screen. And we'll come out of that, and I've just accidentally clicked it in. So we'll go back. and while the file is playing there, back and forth, we can skip, and it's running like a dream. Absolutely no problems, everything running in its original quality, exactly as we would expect to have on a file of this caliber. So now we ramp things up a bit. We make our way back into the Jellyfish files, and from here we probably should take just a quick moment to talk about H.264 and H.265. Now, taking a slight detour, when we talk about H.264 and H.265, otherwise known as HEVC or Highly Efficient Video Codec, these are compression techniques, and these allow large media to be scaled up and down accordingly to the media output device that's going to be utilized. It's how it allows you to watch high-end multimedia that you see in IMAX or the cinema, and then get to watch it from the comfort of your sofa. So over time, these movies that you watch get bigger and bigger and bigger and bigger, but your TV has only increased slightly, and resolutions in the home and file packets and exchange of data has nowhere near reached that scale that the portability of things like digital cinema packages, DCPs, are effective in the wider cinema industry. So although H.264, which was open source, effectively open source I should say, to anyone that wanted to utilize it for packaging their media across the industry, when media was getting very, very large, better and more effective compression techniques were needed. In this case, H.265. Now, H.265 was created by a consortium of pre-existing companies and unfortunately licensed. That's right. If you wanted to utilize it on your media device, and again, this has been going for quite a few years, you would need to pay licensing on the devices to have that. Now, some devices include it, but a lot of devices don't, even popular consoles like PlayStation 4 and PlayStation 5, and these rely on the server to change the file there. For those devices, if you don't have a powerful enough server to convert that file, you may be in trouble. That was why when we were playing that file earlier on using the Plex client application, this laptop that I'm using has a license, and therefore this system was able to take advantage of that. But if your device doesn't have a license or support for HEVC, you're left with a few options. One, your NAS server is going to have to be powerful enough and have the hardware chutzpah to change that file either with integrated graphics or a GPU card or raw system power, or you might be fortunate enough to be using a client device with Plex on it that supports either officially or unofficially client-side conversion and transcoding. That's when the device you're using will use its hardware resources to change that file. Just bear in mind that although that's available and supported on a number of things like MB and Jellyfin, on Plex it is a bit hit and miss there. So again, that's very important when we're looking at the difference between HEVC and H.265 or AVC file types. The other thing to talk about, of course, is bit rates. Now, when we were looking at all of those different files earlier on, you may have noticed over here 3 megabits per second, 10 megabits per second, and that is ultimately the amount of data that is being pushed through at any given time to play back the media. And the higher the quality, the higher resolution, the more pixels, the larger the bit rate you tend to find. And there's recommended minimum bit rates for 720p, 1080p, 4K, even 8K. So as we go through our multimedia collection, the bitrate is going to increase, and you tend to find that bitrate increases work inversely against compression technique. So compression is able, such as in the case of more intelligent and better defined compression techniques where compression is not granular and metric as you see here in H.264, but in HEVC or H.265 it can be more selective about that compression, and that working against bitrate is why you often find with larger files the kind of odd incohesion across file sizes. But that's enough about compression techniques and bitrate. Let's get back to the tests. So again, we've already tested this file here, so we're going to jump up immediately to 10 megabits per second H.264. If we play back this file here, it will play back in its original quality, and as you can see there on the right hand side of the screen, bandwidth has gone up because we're transmitting more data through, but again it's still megabits and we're running on a gigabit internet network here. So again, CPU, nothing really to worry about too much there. If we come out of that file, this time we'll play an HEVC version, which should in theory play fine on this without conversions, because we have that supported license there, although we will hit some audio streams later on where it may present itself a problem. But nevertheless, have you noticed down here, there seems to be a slightly larger bump given we're playing the HEVC version, regardless of the fact that we are running exactly the same bitrate file. And even when you break down to the size of those files themselves on the server, they are largely identical. But more on that later. Now we'll go for a 30 megabits per second version, and we're just going to skip straight ahead into HEVC files there. We're going to let it take a little moment to play its file. It had needed to a little bit more time to think, and we're definitely going to see that reflected on the CPU utilization on the right. Ignore activate Windows. We are using a portal VM in order to get this job done. But as you can see there on the left hand side, we're still playing it, CPU not too troubled there. And if we head back into the temperature gauge there, we can see that although we saw that spike from earlier, temperature has not really gone too bananas for that CPU. And indeed, utilization hasn't been too bad, apart from when we've been doing some early transcoding efforts there. So now we're going to scale up to 100 megabits per second. So this is more than 30 times the first file that we looked at there. So we go ahead and go for the HEVC version, and this is where the kind of size of the files that we're accessing over the local area network may be problematic. Now, I'm well aware that we're accessing files that are 100 megabits per second on a 100 megabytes network bandwidth. There shouldn't really be any issues of remote access bandwidth. However, on any busy network, it can be problematic to play larger bitrate files, particularly with the amount of data being pushed through. And I think that's something we're witnessing here, as Plex has effectively spat out what it's trying to do there. Now, if we try to go for the H.264 version of that same file, we can see just how it's going to fare with exactly the same thing. We're not seeing the file even being attempted there on the bottom of the screen there by the server. Not a great sign. Now, let's get relative here. A 100 megabits per second file is still way beyond what a lot of users are going to be using in 2023 for their average file sizes. We'll move on to 4K in a moment, but I just wanted to include that for the sake of the bitrate transition there. It's not a bad result, because this is not your average day-to-day file there, but it's still got a hefty file nonetheless. Whereas if we try to convert this file, as you can see here, we'll use more CPU utilization, because unfortunately in the case of this we are using software transcoding, but at the very least it's still possible for it to try and chew out and reshape that file accordingly. It's still pretty high, and it's had to scale it inefficiently, but it's still getting the job done there. Now, what if we play the same file, but this time using the Windows client? As you can see, it's playing the file like an absolute dream, clearly showing that the limitation there is within the web browser handling that kind of packet of data. We're still seeing stuttering there, as it's still the same system using it, but without the bottleneck that's being caused by the web browser, we're still able to play it. We're still seeing stuttered playback there, and if we minimize that, we can still see the CPU is less troubled. So it's clearly something of a throughput delivery issue here. The memory's not being too troubled. Still, nonetheless, we are seeing a little bit better results for us to deal with there, and it's still quite a hench file for us to be getting on with. Let's zoom out there, because we don't need that big. So let's stop that file, and this time we're going to move into something a little juicier. Now we're going to show our first entrance into 4K. So now we're going to go for an H.264 200 megabits per second 4K file. Now this is pretty huge. If the 100 meg going through was going to be problematic, this is the 200 meg version of that file, this time in 4K. And again, it's more of a content delivery issue here than it's anything to do with the CPU on that NAS being in any way problematic. As you see there, this could simply be the fact that we're running OBS here. If we go ahead and open up our task manager, we're about to see how my GPU and CPU integrated graphics are being hit, and the GPU is being quite heavily taxed by this, as you can see here. If I move that more on screen, bring that out onto the GPU, we can see that it's largely my system that is performing something of the bottleneck there in order for this to be handled, which again shows you a lot more about the how the performance dip that can happen if your client device isn't quite suited for this level of bitrate. Bear in mind this is nothing to do with the file being 4K, something I'll show you in just a moment. But for now, while we come out of that, let's go into some actual 4K there. So these are 4K trailers. We're not going to go through all of them, but we're going to go through several of them to prove a point. Now this is a 60 megabit, actually we'll go for the 12 megabits per second into the Cave of Wonder native file here. Now this is a 4K file. It's running at 12 megabits per second bitrate. As you can see, we're playing original quality there. We can skip ahead and we're doing absolutely fine. Once again proving that we are seeing something of throttle, a bottleneck if you will, to do with the bitrate, either to do with my network being overly busy or this system via the web browser just forming something of a stoppage gap there in between. If we come out of that one now we're going to roast duck. Now this is a file that is generally the tipping point for a lot of NAS systems. Now I'm willing to bet if we play it on here, what we're going to see is the file, as we can see, the file was converted, and that is because this is utilizing quite a very specific dense makeup there with the 8-bit HDR MKV. So once again, when we try to play the native version, we're going to see, as you see on the right, quite a significant spike in terms of CPU utilization. If we come out of it there, we can see just how my system is reacting, and once again, this time, because it's in the web browser, it's the web browser that's having to work quite hard there. And although it's playing the file, look at the dark orange at the bottom, it's not able to outpace, the buffering is not able to outpace playback, and unfortunately has led to the file stalling, as we see here. Now, again, if we head back into Plex, and this time utilizing the Plex client application, we go ahead and play back that exact same file. It will play the file natively, and therefore when it's being played natively, it's going to run like a dream. And obviously on my native one here, we're seeing the GPU on my laptop take a lot of the load. Well, at least this time we're seeing the buffering absolutely fine, and we're seeing the file playing back at original high quality there. Lovely stuff. If you are seeing any kind of drop in the frame rate, that may well be to do with the OBS that's running on this laptop having to work particularly hard to record everything we're doing. So that was a 60 megabits per second bitrate file there. If we go for a 30, let's go for an H.264 file here, and this is a 32 megabits per second H.264 file here. So this now means we should be playing in the original quality, which we are, but we're also pushing through 30 megabits per second bitrate here. Now 30 to 60 is where we start to see problems accessing files like this on light reconverted browser tabs. I think I should have mentioned earlier on, I believe I didn't, was that when you're utilizing a lot of client devices, forget your Amazon Fire TVs, going for slightly more off-the-shelf multimedia devices, a lot of their client apps are just reconverted browser windows, and this will be the result of what you'd see if you try and play back that file in that fashion. Now, as mentioned earlier on, if we convert this file, it'll play, and it even will convert it into an incredibly similar version of the file we're trying to play in the first place. But nevertheless, there is something of a bottleneck there forming between my client playback device and what we're seeing here in front of us, likely caused by no small part by OBS recording here, but obviously that being more impactful when we look at the playback if we were using the client tool. As we can see at the bottom, we are playing the file now. It's managed to perform that conversion automatically, but it's still not great, and buffering is not staying hugely ahead of playback. The conversion is largely identical, as we can see there, but still nonetheless, it would have been nicer to see some better results there overall, with CPU spikes being quite substantial, and no doubt, as we can see, the temperature being generated by this system while we're doing it to be pretty darn high there. Not nightmare high, this is actually quite a good temperature for a system to be running. To put that into perspective, my host system now is probably getting quite extraordinarily hot on the GPU, as it's a laptop there. Now coming out of that, we'll run just a couple more tests. For this one, we'll make our way down to a lower bitrate file, but this time we're going to be going for a lower bitrate file in H.265. So for that one, let's go ahead and run ourselves. Let's have a quick look for a lower bitrate in H.265. We're going to go for Beauty of Taiwan. 30 megabits per second file. Again, it should play us back in a converted state, as we can see there, and it will convert the file, and the CPU utilization is once again going to see that spike as we've come to anticipate over time. Let's go for the net data version. Trying to minimize it there so we can see a little bit more information about this CPU when it's being utilized there, and it will play, but of course buffering is going to take its time, something we're seeing there at the bottom of the screen. Had it been playing natively, it would have been absolutely fine, but once again this still comes back to the idea of this system not utilizing hardware acceleration by default, and it's just another reason why pursuing these guides on how to enable that hardware transcoding or hardware acceleration is going to be pivotal to a lot of users. Of course, if you're running a system, once again, that can play back these files natively, you're going to be absolutely laughing there. Just be aware that if you're not running a system that can play these files natively, and particularly if you're going to be utilizing, as in my case, OBS, that's really going to crunch how much CPU utilization you've got to play with, and GPU utilization, then that may form a factor. But right now, this Topton build inside the Jonsbo case is certainly going to be okay for a lot of native 4K. I don't see any problem there, but if you're going to be relying on transcoding and encoding and any kind of converting of files, then chances are you're going to have to go down the route of, you know, getting a bit techie and re-enabling iGPU by making your way in. I think it's dev.dii or dir/dev even, to dig in a little deeper to enable that iGraphics as mentioned. We did a guide not dissimilar to this for Synology and QNAP that were running. There was a Plex fix to go into the preferences.xml for Synology and QNAPs when they were running the previous generation CPU from Celeron in this family to enable that, and in TrueNAS, unfortunately, less so in scale but definitely in core, you're going to have to do a lot of playing around to give Plex access to the hardware acceleration. Now, let's end this video on just a little bit of 8K, because we've got some 8K files here, which, let's be realistic, are almost certainly not going to play here in the web browser. They're all going to be HEVC, and until VC1 codec and some of these other compression, not codec, compression technique, I should say, rolls out more widely across the industry, unfortunately, 8K is largely locked behind HEVC domestically in a lot of places. If we go ahead and try and play back one of these files, for example, in VP90, which it will have to convert due to a lack of support of that, unfortunately, we're not going to see fantastic results overall. It's still going to have to compress, not compress, it's still going to have to convert, and we're seeing the CPU attempt it, but as we look here on the right hand side of the screen, CPU utilization is quite substantial as we roll in to play back this file eventually, and it will play this file presumably at a quite horrific frame rate, but it will play it back nonetheless. But that playback there, it's reached perhaps 8 to 9 seconds. There's no way that native playback is going to be behind buffering, and ultimately, even if it plays, which it's briefly doing, it's going to stop any second now, something that's largely unavoidable, as you can see there. But what about if we try with the native tool here from Plex? Using the native tool, we can make our way in, select the 8K test files there, and go for that exact same file. Where is it? VP90. And from there, yes, we're using quite a beefy system here. It's playing in original quality, and there's going to be a drop in frame rate, but it is able to host that file for us here if we had the network bandwidth to do it. Of course, some of you may have noticed that my system here has gone into power saving mode because we're trying to maintain the battery because we've had to disconnect power, but for the rest of this video we have been in full CPU utilization there with no limitations, and now we brought that back, we can try and replay that file. Let's go ahead and go for this one here. This is another one, 60 frames per second HDR HEVC file here. Open it up, and we are still playing at original quality. The frame rate is absolute nonsense, and 8K Plex media streaming is by no means mainstream at this point, with Plex themselves not really officially supporting it that much, but it's still nice to know that as long as you've got the hardware client support on your side for Plex media server, so that means even if you've got licensing support of HEVC, or you've run a system that has the privilege or the power, both together, to convert the files, the Jonsbo N2 with that setup there with the Topton the Topton board on the N5105. It's still a great little setup there. And remember that price point that this system rolled in at here, $247 without the TrueNAS installation. Unraid license will cost you more, as long as you're not going to be overly reliant on conversions and transcoding, or you want to take the time to enable it with some of the modifications, thanks to a couple of those links that I'll put below. It's still a great system for Plex Media Server. And in terms of temperature, although we've seen some high numbers there, 67 degrees for a CPU isn't actually that harsh in the grand scheme of things of what we are doing. But this has been Plex Media Server testing of the Jonsbo N2 and Topton N5105 build. Thank you so much for watching. I hope you've enjoyed this. Remember, links to everything we've discussed are below, alongside other videos on this subject. We're going to be revisiting this box and the Jonsbo N3 very, very soon, so check that out. Thank you so much for watching. Comment below if you've enjoyed the video. Even if you haven't, feedback's always useful. And of course, stay tuned as we explore this subject more. Use the free advice section, the free Discord, the Ask Community, Ask NAS Compares forum, or free for early access to a lot of these videos. Head over to Patreon and Ko-Fi, where we have both free and paid tiers to access our monthly seminars, more videos, expedited support, and access to these videos in advance. I'll see you next time.